What's up, guys? So today we're talking about solving systems of equations still, dealing with that elimination method, but we're going to look at a couple more complex systems that we could solve still by using this method. Not every time we're going to have x's or y's line up exactly. Sometimes we're going to have to multiply to make them line up, and that's what you're going to see today. I can learn the procedure of elimination using multiplication. So our steps for solving this system: step one, put them in standard form. Step two, determine which variable to eliminate. Step three, multiply and then solve. Before, we were finding which variable to eliminate based off of the numbers, the coefficients with them. If they were the same, we either add or subtract. This time they might not be the same, so we're going to have to multiply to solve for that variable. Step four, plug it in, find the other variable. And step five, just like always, check your solution. Here's example number one. Look at this system. You have x plus 2y equals 6, 3x plus 3y equals negative 6. X and x, no, doesn't match. 1x, 3x, no good. 2y, 3y, again, doesn't match up. 6 and negative 6 match, but we want to eliminate a variable, not the constants. So right now, elimination, we couldn't really do until today. Multiply this thing to make them match. I'll tell you right now, it's going to be easier to multiply this top to make it match the bottom. Because if I times 1 by anything, it just becomes that thing. I don't have to change anything else. So looking at this one, I'm going to multiply to get those x's eliminated. I'm going to multiply by negative 3, because if this becomes negative 3 plus 3 goes to 0, goes away. So now I'm timesing everything by negative 3, which means this x becomes negative 3x. Negative 3 times 2y becomes negative 6y. Negative 3 times positive 6 becomes negative 18. Now I have my system. It'll get us the same answers, but now I have my system. And you'll notice the x's have the same coefficient, just opposite signs. I could add these together. Negative 3 plus 3 goes away. Negative 6 plus 3y becomes negative 3y. Negative 18 plus negative 6 becomes negative 24. Solve for y. I get rid of that negative 3 by dividing. Negative 24 divided by negative 3 becomes positive 8. So I have y equals 8. We could use that for half of our answer and plug it in to find what the x value is. Going back to our original system, which one's easier to deal with? Looks to me like the top one's easier. That's a typo there, guys. That should be a y equals 8, because we got 8 there. So we're going to plug 2 times 8 in there, which makes 16. How do I get rid of plus 16? I minus it. So 6 minus 16 gets me a negative 10 for my x value. So my final answer here, negative 10, comma, positive 8. Still eliminating, still finding the leftover variable, and then using that to find the second variable. So same steps. The only thing is sometimes you're going to have to multiply to make them match up. There's example one. Take a look at this one. This one's a little bit more complicated. We're in standard form already. I have 3x and a 2x, doesn't match. I have a 4y and a negative 3y, still doesn't match. Negative 25 and 6. So I'm trying to match these together. Can I multiply 2 by anything to make it 3? No. Can I multiply negative 3 by anything to make it 4? No. So this is a case where we're going to have to multiply both equations to make them match a number. Think about numbers that 3 goes into and that 2 goes into. 6 has a 3 and a 2 go into it. So we want to change the x's to become 6's. To do so, we're going to multiply the top by positive 2 and then multiply the bottom by negative 3, because 3 times 2 makes positive 6. 2 times negative 3 makes negative 6. So now multiply these things out. 2 times 3x becomes 6x. 2 times 4y becomes 8y. 2 times negative 25 becomes negative 50. On the bottom, negative 3 times 2 becomes negative 6x. Negative 3 times negative 3 becomes positive 9y. Negative 3 times 6 becomes negative 18. So here's our new system since we multiplied it out. And with multiplying it out, we could cancel out the x's because they're the same coefficient, just opposite signs. So let's add the rest of this together. I got 8y plus 9y, which makes 17. The negative 50 plus negative 18 makes negative 68. Solve for y by dividing by that 17. Negative 68 divided by 17 becomes negative 4. So we have half of our answer. We have that y equals negative 4. Now let's use that and plug it back in to find x. Looking at our original system, which one looks easier to you? I'm going to plug it into the bottom one. I have a 2 and a 3 instead of a 3 and a 4, and a 6 is way smaller than a 25. So I'm going to plug it into the bottom one. Our y was negative 4, so instead of negative 3 times y, I'm going to have negative 3 times negative 4. Negative 3 times negative 4 becomes 12. Get rid of that plus 12 by subtracting it. 6 minus 12 becomes negative 6. Get rid of that 2 by dividing. Negative 6 divided by 2 becomes negative 3. So our final answer, negative 3 comma negative 4. Focus on your system, same way. X's and Y's, which ones can it eliminate? They might not eliminate right off the bat. So multiply to make them eliminate. If you have a 1 as a coefficient, that invisible coefficient, that's the one you should aim for because that's an easy one to change. Otherwise, you have to look. And sometimes, like what we just saw in this problem, you had to multiply both equations to make them match. You guys try these ones here. Don't worry about solving the whole thing. But tell me, what are we going to multiply for number 1? How are we going to get either the x's or the y's to eliminate? Now for number 2, what are we going to multiply by? If we continue to solve this all the way through, guys, for number 1, we would have gotten 3, 1. For number 2, we would have gotten 8, negative 2. That's it for this video. Please email me with questions if you have any, and then we'll see you later on in class. See you guys later.